How do you calculate the carbon footprint of an aluminum profile? We generally follow a cradle-to-gate approach using the cut-off method, as this is the simplest and most transparent method. We often see in the market that the carbon footprint of an aluminum profile is calculated simply by adding together the CO2 value of the billet and the CO2 emissions from the extrusion process. However, this is not correct, as it understates the CO2 emissions. Why? According to the cut-off method, all emissions are attributed to the end product, in this case an aluminum profile, while the scrap generated during the process has no carbon footprint. Due to technical reasons, approximately 1.3 tons of aluminum billets are required for 1 ton of aluminum profile, which is referred to as the requirement. For the CO2 calculation, the total weight of the aluminum billet is used, including the requirement, as the basis. Otherwise, the carbon footprint of the 0.3 tons of scrap produced would disappear, resulting in carbon leakage. Let's look at a calculation example for the production of an aluminum profile from billets with a European standard value of 6.7 tons of CO2 per ton of aluminum and a requirement of 130%. For 1 ton of aluminum profile, I need 1.3 tons of aluminum billet with a footprint of 6.7, so I calculate 6.7 times 1.3 plus the process emissions from extrusion, which in this case we assume to be 0.19 per ton of aluminum profile, meaning that the aluminum profile has a total carbon footprint of 8.9 tons of CO2. If the requirement were not taken into account, the value would only be 6.9 tons of CO2 per ton of aluminum profile, and the difference of 2 tons would simply disappear. This would systematically underestimate the environmental impact of the profile. Therefore, the requirement must be taken into account when calculating the CO2 value.